Bismillahirrahmanirrahim. Assalamualaikum and hi everyone, especially to our lecturer Dr. Amalina and other friends. How are you guys? So hopefully you are in a good mood and stay safe. I am Nurul Ain Hazira binti Jamal with metric number 11823112. Today, me and other members of the group Ashikin, Shahira, Shamimi, Adina, and also Sali Sajida want to present more details about the batch reactor and semi-batch reactor. What can I say before we expect more about this topic is batch reactor is the most important part of system to undergo some process fluently. It is like the heart of a system. Alright, so we go to the definition of the batch reactor. First and foremost, I will explain the introduction of our topics. The batch reactor is the simplest type of reactor. Likewise, in a laboratory, the reactants are placed in a test tube, flask, or beaker. They are mixed together, often heated for the reaction to take place and are then cooled. The products are poured out and, if necessary, purified. This procedure is also carried out in industry. The key difference being one of size of reactor and the quantities of reactants. So next, the materials are loaded into a batch reactor, and the reaction proceeds with time. A batch reactor can control temperature, pressure, and volume is often necessary. Many batch reactors therefore have ports for sensor and material input and output. Batch reactors are typically used in small-scale production and reaction with biological materials such as brewing, pulping, and production of enzyme. Brewing means the activity or business of producing beer. Meanwhile, pulping is a process that extracts fibrous material, cellulose, from wood or other raw material as a prelude to paper making. Alright, so after the introduction, the batch reactor would define as the generic term for a type of vessel cylinder thing which widely used in the process industry. A typical batch reactor consists of a tank with an agitator and integral heating or cooling system. Heating or cooling uses jacketed walls, internal coil, and internal tube. Alright, so we go to the type of reactors. We have batch reactor, flow reactor, and other reactor types. So this is the picture of batch reactor in a way of animation and industry. Besides that, we also have flow reactor. For instance, continuous stir tank reactor CSTR, plug flow reactor PFR, packed bed reactor PBR. A flow reactor is a device in which chemical reaction take place in microchannel. So this subtopic will be explained more by other groups. Alright, so other reactor types, we have fluidized bed reactor and also trickle bed reactor. Fluidized bed reactor, which is type of reactor that can be used to carry out a variety of multi-phase chemical reaction. Meanwhile, for the trickle bed reactor, means that chemical reactor that uses the downward movement of a liquid and the downward or upward movement of gas over a packed bed of catalyst particle. So this topic also will be explained more by other groups. Alright, next, let me show you a diagram of batch reactor. So this is the diagram of batch reactor that can we see. So we have two places for reactant to enter the column, this column, and then we have electronic valve control, we have level gauge, we have two vent system, products will overflow from reactor, and this is stirrer, and we have coolant, and also we have flow level. Alright, so Ashiki will explain more on how it works.
Hai, Assalamualaikum. I am Narashiki Metika Muruddin. I will explain about how batch reactor works or how it functions. So here is a simple diagram of batch reactor. As we know, batch reactor is a closed system with no continuous flow of reactants entering the system or products leaving the system while the reaction takes place. And the reaction mixture can react a long time in order to reach high conversion. So this is vessels for reactant 1 and reactant 2, and this is the controller. This will control this valve or vessel, this valve, and this is vessel for product to flow out from the reactor. And this is stirrer that we have the reactant to react. And this is coolant to cool the product if needed. And this is vent for the product for any heat to out if the reactant is heated. So reactant 1 and reactant 2 will flow into the reactor and react for a long time to reach the high conversion, and the product will flow out and will be purified if needed, or the reactant will be heated for reactants react or for the reactant take place, and will be cooled. If in laboratory, the experiment will be carried out by using test tube, flask, or beaker. The reactants will be mixed together and then heated, cooled, and flow out. That's how batch reactor works. Easy, right? That's all for me. Thank you.
Okay, now moving on to the application for batch reactor. There are three: colorant as a color to make colorants in the pharmaceutical industry and for fermentation process. Okay, first, in colorant, what is colorant actually? Colorant are used in many industries to color clothes, paint, plastic, photograph, print, and ceramic. Colorants are also now being used in novel applications, for example in surgery. Colorant can be either dyes or pigment. So, In colorant synthesizing process, the colorant are being produced in a batch reactor. The top of the reactor is at a flow level, and the rest of the reactor is suspended below it. And next, in pharmaceutical industry, batch reactor is used in pharmaceutical industry for the production of drug, where a rapid and precise temperature control is very necessary. It also requires consistent and a high quality result. This is because drug is for us a consumer to eat when we get sick or when we need a medicine to cure any disease. Okay, next, in fermentation process, in batch fermentation, all nutrients necessary for cell growth and L-lysine production are present in the medium from start. And the batch fermentation is started by inoculation with biomass from a set reactor. Okay, what is inoculation? Inoculation is the act of introducing microorganism or suspension of microorganism into a culture medium. So the culture medium is inside the set reactor, and then the batch process is finished when nutrient, typically the carbon source, have been totally consumed. Okay, that's all. Moving on to semi. Okay, now we are going to moving on to the advantage and disadvantage for batch reactor. The advantage is it have high conversion if we leave the reactant in the reactor for an extended period of time. But the downfall is it have a high cost of labor per unit of production. Another advantage is it is good for producing a small amount of product while it is still in testing phase, because it is difficult to maintain large-scale production while we are using the batch reactor. And the last plus point for the batch reactor is it is very easy to be clean.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Nur Shamimi Filza, and I will be continuing the presentation by presenting the next type of reactor, which is semi-batch reactor. Okay, first of all, we're going to see what is semi-batch reactor. Okay, semi-batch reactors operate much like batch reactors that both take place in a single stirred tank with similar equipment. As we can see here, there is the tank and there is the stirrer that will be needed in both batch reactor and semi-batch reactors. Okay, however, in semi-batch reactors, they are modified to allow reactant addition or product removal in time. So it has been illustrated in this diagram where reactant A already been added into the tank. Then during the reaction, reactant B will be added continuously. Okay, so semi-batch reactor has an open system because we can keep on adding the reactant during the reaction. And it is also low partial filling of reactant. We can either add both reactant into the reactor or just one type of reactant into the reactor. And it is an unsteady state system. Okay, so semi-batch reactor can be either in these three situations. First of all, reactor in which both volume and composition change. Okay, so as we can see the diagram here, in this tank it is already filled with reactant A, and during the reaction we just keep on adding reactant B. By adding reactant B, of course the amount of reactant mixture in the tank will increase, so the volume will change. And as we just add reactant B into the tank, while reactant A remain the same, the composition will also change. Okay, next, the second situation is reaction in which volume change but composition remain constant. Okay, as we can see the example here, we already add the same amount and composition of both reactant into the tank. Then during the reaction, we will be added both reactant again into the tank. So for example, if we are adding 10 ml of reactant A, we will also add 10 ml of reactant B into the tank during the reaction. So this will result in increasement of volume of reactant inside the tank. However, the composition will remain constant as both reactant will be added with the same amount. Okay, next, the last situation is reaction in which composition change but volume remain constant. Okay, as we can see here, there is a bit different about the tank here. Okay, we have this part where we can discard the product. So during the reaction, even we are adding reactant B, the volume will remain constant as when the mixture of reactant achieve or reach certain volume, it will be discarded. However, the composition will change because we only add reactant B into the tank while the reactant A will just remain the same in the reactor. Okay, so now we'll see how the semi-batch reactor works. Okay, so based on this video, we can see that first of all, there is the first reactant has been added into the reactor. So let's say this is reactant A and this is reactant B. So first of all, we add reactant A into the reactor, then we start the reactor. Only after that, we add reactant B. So after both reactant mixed together, the product will be formed and then it will be discarded out of the reactant. So here we can see that we add reactant A, then we start the reactor and we add reactant B. We get a product and we will be discarded out from the reactor. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adlina binti Muhammad Zalani. I will present about the application of the semi-batch reactor and the comparison between both type of reactor. First, we go to the application of the semi-batch reactor. Semi-batch reactors are not used as often as other reactor types. However, they can be used for many two-phase reaction, such as solid-liquid phase reaction. Also, semi-batch reactors are used when a reaction has many unwanted side reaction or has a high heat of reaction. By limiting the introduction of reactants, potential problems are eliminated. The first application of semi-batch reactor is production of penicillin. Most drugs are produced as a semi-batch process. Penicillium mold naturally produce antibiotic penicillin. Scientists learn to grow the penicillium mold in a deep fermentation tanks by adding a kind of sugar and other ingredient. Penicillin is produced by the penicillin fungus at low concentration of glucose. It is essential to periodically add glucose to the reactor to supply the fungus with nutrients. Then they separated the penicillin product from the mold. Penicillin purified for use and antibiotic medicine. Next is saponification. Saponification is a process that involves conversion of fat, oil, or lipid into soap and alcohol by the action of heat in the presence of aqueous alkali such as sodium hydroxide. Initially, in this process, we fill the tank with the sodium hydroxide and then fed the ethyl acetate periodically. Sodium hydroxide is in the batch mode, while another reactant, such as, for example, uh, ethyl acetate, is in the continuous mode. Next is esterification. Esterification occurs when carboxylic acid react with alcohol. Esterification with an unwanted consecutive reaction. In esterification, monoester will be produced. Monoester that has been produced can react with the alcohol and produce diester. To reduce the production of diester, higher concentration of acid is added to the reactor and we add the alcohol over time. In this reaction, acid is charged at the beginning of the process, while the alcohol is continuously fed to the reactor. Next is comparison between batch reactor and semi-batch reactor. First, we go to the similarities of the both reactor. Both reactor is in unsteady state. Also, semi-batch and batch reactor both need high labor cost. And lastly, it is difficult to achieve a large production, large scale production if we use batch or semi-batch reactor. Next is the differences between a batch reactor and semi-batch reactor. Batch reactor is closed system, where semi-batch reactor is open system. What is closed system? Closed system is when no reactant flow into the system and none of them is leaving the system until the end of the reaction. While the open system is semi-batch reactor will have some addition or removal during the course of the reaction. Batch reactor cannot control contact time between reactants, but semi-batch reactor can control contact time between the reactants. That's all from me. I will pass to the another person.
Assalamualaikum warahmatullahi wabarakatuh. My name is Salih Sajidah binti Osman 1182304, and today I will be continuing the presentation on advantages and disadvantages of semi-batch reactor. So, the first advantage of semi-batch reactor is that it can minimize our unwanted side reaction. And why is that? As we know, there are certain reactants that when they are reacted together, they can produce more than one product. For example, A react with B, you can produce D, or A when it reacts with B, it can produce U. But of course, between those two, there's something that we desire and we don't want. So, let's say product D is our desired product, thus this is our desired reaction. And U is our undesired product, and thus this reaction is our side reaction that we don't want and we want to minimize, because of course industry always want to be profitable, so we have to reduce things that does not benefit the industry, right? So let's say, how does that occur? Let's say the rate constant it multiplies with the concentration of A and concentration of B at the power of 1, and for the second equation, the rate constant, the concentration of A is at the power of 2. So, in order for us to maximize our desired reaction, we have to ensure that the concentration of A is as low as possible, so that it does not produce this kind of equation, the second equation. So to make it possible, you have to flow A into B and not B into A. Okay. So you already have your reactant B in your reactor and you flow A afterwards into it slowly as you're charging the reactor. So that's how you are going to maximize your desired reaction. However, it is B into A if U is your desired product, for example. If U is your desired reactant, your desired product, so yes, B into A. So why is that? Because when A is low, right, the concentration of A, the moles of reactants of A inside the reactor is low enough, you can actually maximize the production of D and lowering the production of your unwanted, undesired product, which is U. There are calculations that is involved. I just use a graph generator, but there are calculations that will be involved, integration, and so on and so forth, which you can refer to this link. But you can see the idea of why semi-batch reactor is good, because you actually control how much you want to flow, how much of a certain reactor you want to flow into the reactor. So secondly, so to overcome sparingly soluble reactants. For example, you want to perform a hydrogenation process, right? Hydrogenation reaction, right? But the concentration of the hydrogen that you obtain is quite low, so you have to continuously supply hydrogen to your reactor, in order for that reaction to occur. So that's the good thing about semi-batch reactor. You can continuously flow in another reactant into reactor. Thirdly is good temperature control. And why is that? Okay, let me give you an example. Let's say when reactant A is reacted with reactant B, you produce C. However, it's an exothermic reaction. There are certain reactions that are exothermic reaction, right, as we know. So when it's an exothermic reaction, it gives off heat. When it gives off heat, means the temperature will increase in the reactor. And when there's an increase in reactor, what does it mean? Increase of temperature in the reactor, what does it mean? It basically means you're increasing the rate of reaction. So as we know, if you increase the rate of reaction, the exothermic reaction will give off more heat, and not only it gives off more heat, it gives off more heat at a faster rate, and the temperature will rise faster, and then the rate of reaction will proceed faster, and the continuous cycles until it's so fast you can't control the temperature, and that will be a safety concern. It's a safety concern. As much as we want to produce a lot of product, you have to take in consideration those factors, safety concerns, and so on and so forth. However, let's say you have product A, you have reactant A, react with B, produce C. You control the time of A reacting with B. You control how they contact each other in the reactor. Okay. You control how A flows into B, how fast you want it, the flow rate basically. So from there, you can ensure that the rate is not too fast to the extent it produces too much heat, and you can ensure the temperature is controlled. So if you like this graph, right? Okay, let's focus what happens at 50 degrees Celsius. A and B is already reacting with each other, giving more heat, and the reaction becomes so fast. So as you see, in a span of a few minutes, it already increase in temperature very fast and very high in the batch reaction. But if we say semi-batch reaction in the semi-batch reactor, right? First, let's say this is your reactant B, but only after a certain period of time, then you add reactant A, or you add reactant A very slowly, so that the reaction occurs slower and more controlled, to the extent in the reaction progresses. You can control the progression of the reaction so that temperature does not increase too fast, and you can so that's a good thing about semi-batch reactor. Next, you can minimize reversible reaction. So as we learn at in Le Chatelier's principle, there are certain things in a reaction where there will be a response in the reaction in order to overcome the stress that is in the reaction. For example, right, A plus B and the concentration of C is low. So when the product is low, they will always want to have a forward reaction to ensure that it can actually respond to this situation, right? Because in the industry, basically, we want to produce as much as product as possible. So we don't want the equation to be reversed backwards. We always want the reaction to move forward, right? So in order for those reactions to move forward, what you can do with the semi-batch reactor, basically, you can flow out the product. You can remove the product at a certain flow when this reaction is happening in the reactor. So when it's removal product, there will be a forward reaction preferred, because they want to overcome the decrease of concentration of product in your equation, because you want to be equilibrium. Alright, that's all for the advantage. Let's look at the disadvantage. So basically, all these disadvantages, they are very closely related, okay? So as you can see, there were many complex calculations that you have to take in consideration, which is basically number one, sometimes the concentration of your reaction, the flow rate, the flow rate, the contact time, the volume, and so on and so forth. It's a more complex calculation, so it requires further complex understanding and analyzing. Okay, so people have to do experiments to ensure the product is maximized. Requires piping and valving, and the operating cost is quite high, and it's a complex open system, because as we know, a semi-batch reactor, it's an open system, right? It's an open system because things flow into it, or product flows out of it. So it's expensive because it requires piping and valving and operation costs, which also I have a close relationship with it being difficult. It's going to be difficult in a large scale, because basically batch reactor and semi-batch reactor, it's always done in a small scale, because if you want to scale it up, it's not as easy as this ratio to 2. It's not like, because all the calculation that you did for the small scale, you can just multiply it by 2 if you want to make 2 times bigger. No, because then your valving will be more expensive, your mixer will be more expensive, and how do you control the concentration at those large volume? So there's so many things that should be considered in maximizing the cost, in minimizing the cost, maximizing the product and efficiency. And it's also difficult to analyze. Just like I stated earlier, there are so many calculations that are involved, like an engineer. Okay, so that is all from our group on batch and semi-batch reactor. So thank you for listening. Assalamualaikum.